you want to scroll through the display, just give it a knock. A button would need a rubber seal on it because these go indoors or outdoors. So if you see me, knocking on the inverter, it's not because it's broken. I'm just waking it up to show the backlights. Pull this guy off. See a little better. Okay, so these are inverters. These are turning DC power from the panels into AC power synchronized with our grid power coming in. So this whole roof up here, you guys look up, the one facing south, that's just totally covered in solar panels. Again, just that roof continues all the way to the front of the building. The conduit from those panels comes down on the edge right here, comes through this 2-inch conduit. You see that silver conduit there with the red sticker? It says caution, solar circuit. That's a reflective sticker for firefighters. Since those wires are always energized, we don't want firefighters chopping into that with their axe if they're trying to rip into a building. So that's part of code that we have to follow to make these systems safe. Anyway, that conduit of DC wires comes down. Let me actually grab a wire for you real quick so you guys can pass it around. It's pretty heavy duty. It's UV resistant. It can be indoors or outdoors or buried directly. You guys can pass that around. So we can bring 3,000 or 4,000 watts through every one of those wires. So we'll build a harness as part of our installation to gather all that DC power. DC is direct current, so you have a positive and a negative. I probably should mention that. So our DC power comes down into this wire trough down here, and we split it up into the correct inverters. And then the inverter basically manages everything from there. And there's nothing that we have to control, or we don't have to go to our solar circuits and plug in our solar devices and things like that. Everything works just the way it normally would. This inverter takes care of all that. So right now, this is handling 1/3 of that system that's up there. This is handling another 1/3, and then that one up front is handling the front 1/3 of it. So it's kind of split up into smaller inverters. We could have possibly used one big inverter, but it wasn't quite the right size here, so we split it up into 3. But this one inverter is making 2,200 watts right now. The sun is actually way over to the east right now. It's not on the panels directly. At its peak, this inverter will make 6,000 watts. So around noon today, it's probably going to be making between 5,000 to 6,000 watts. When you think about watts, you guys are lucky enough, you're growing up with compact fluorescent light bulbs, LED light bulbs. You probably don't see a whole lot of incandescent light bulbs anymore. They kind of get too hot to touch after about 1 or 2 minutes of being on. The reason those get too hot to touch is that they're wasting a lot of energy into heat. So LED light bulbs, compact fluorescent light bulbs are much more energy efficient. But if you have ever seen a 100-watt light bulb, that'll burn the heck out of your hand. That's 100 watts. So you take 10 of those, that's 1,000 watts. We call that a kilowatt. So if this inverter will make 6,000 watts at its peak, that's like taking 60 of those 100-watt light bulbs and just leaving them cranking, just maxing out. It's also the same output as like what an air conditioner draws, a big air conditioner when it's running at full power. So maybe kind of gives you a little bit of a reference. A space heater that's 1,500 watts. So let's take 4 of those space heaters and just leave them on all day long. That's kind of what this thing's doing, but in reverse. So this one's making 2,300 watts now. The sun's starting to come up. This one's making 2,300 watts. Since we don't have any shade, the one up front is probably making 2,300 watts. So we're at about 7,000 watts right now of power. Just a lot of energy. We're probably not, we're probably maybe air conditioning a little bit, depends on when they're cycling on and off. Let's walk around the side here and we'll take a look at the rest of it. So these inverters, they have AC output. Comes out through this conduit, into that breaker panel, and then it's combined all into one output that goes back outside. And it's completely blocked by solar panel pallets. Sorry. Let's see, this one is actually, let's have the air conditioners going, because this one is, we are buying power from the grid right now. So I'm guessing the air conditioners are on, maybe a little bit more than I thought they were. But there's a solar disconnect switch, so if firefighters need to come, or if Westar, our power company, needs to come and service the electrical lines, they can shut off our system right there with that switch. What kind of questions do you guys have about the solar, the physical part of it, the technical part of it?
Well, so the one out there that you showed us that you said was more expensive.
Yeah.
So is it meant to provide shade?
Yeah, that's part of it. We could have used a little bit simpler panels there. Those are special frameless, clear panels, more of an architectural detail. But yeah, we use solar panels to provide shade pretty often, actually. Yeah.
How much time have you guys had this solar panel?
This has been up for maybe operational for maybe 8 months or so. We've been here a year now, haven't we? Yeah. Almost a year. I think we took possession in July. You know, we were pretty busy last summer too, so it took us a while to get our own solar up. It's a bit cooler in the shade if you guys want to step back in there. You want to give the launching demo? So this is the real deal. Sorry. This is an actual solar panel. Typical house will use about 24 to 60 of these, depending on if they have a pool or not. People with a swimming pool, they can use more of these than typically their roof can handle. But most houses with typical energy usage, 20 or 30 panels will cover all their power for the year. This is kind of the standard size now. They used to come in lots of different sizes, typically a bit smaller or a bit taller than this. But the industry's really settled on this because it's about as big as one person can safely handle up on a roof. It's sloped, it's windy, but one person can move these on and off the roof pretty much all day. They're about 45 pounds. It's tempered glass, and it has kind of a texture to it, so the light doesn't bounce off. Sometimes people ask us, our neighbors will ask our clients, is this going to glare? Is this going to shine light directly in my windows? That really doesn't happen because it's designed to absorb sunlight and make full use of it. So it's tempered glass, like a car windshield. It'll handle hail just as well as a car windshield. Sometimes people ask about insurance or damage, things like that. If you get hail bad enough to damage your panels, you're going to be replacing your roof. Your insurance agent's going to be on site anyway, assessing the damage to your car and pretty much everything else around you. They're extremely durable. They've blown off of carports before. We've had arrays hit by tornadoes. That particular case, 10 panels out of 60 did get shattered. They were hit by metal debris. Kind of no accounting for that. But they are extremely durable. They're built to last 30 to 40 years.
Wow.
So it's a pretty permanent installation. What other questions?
Guys, don't be shy. Feel free to ask questions.
Yeah.
So what is the difference in cost between that and the, what do you say, microinverter array?
Oh, sure. Well,
Cost prohibitive.
we can use this panel on microinverters or string inverters.
Okay.
The inverter really just it changes how the power is transmitted to the grid. If we have to switch to microinverters, that typically adds 5 to 10% to the total price. So it's not a crushing amount, but if we can avoid it, we can.
Could you maybe briefly go over the technology behind it? Because I don't get it. I don't get what each of those things do.
Yeah, I should have started there. Okay, so these little blue squares, these are called cells. Before they're cells, they're called wafers. So I'll step back a little bit. It's crystalline silicon. So they take silicon, they purify it to 99.99% pure, and they dope it on. They treat one side differently than the other side to basically create a positive negative junction, a PN junction they call it. So it's one of those things that's difficult to explain in words, but you kind of get the concept. So it starts with molten silicon, very, very pure. They let that form into a crystal, and then they slice it into little tiny wafers. The wafers, depending on the manufacturer, they're typically about 0.5 millimeter thick. When sunlight hits those wafers, it creates a charge that's different on the back from the front. It's about 0.5 volt. So you think a little AA battery, that's 1.5 volts. So it takes 3 of these cells to make that same voltage. To capture that voltage, they have this wire grid on them. You see the shiny bits here. It looks kind of like a net. That is capturing electrons on the front, and then there's a similar grid of wires capturing electrons on the back. If you guys come in here really close, you can see these wires. It's a silver ribbon. It goes on the top here, and then it goes underneath the other one. This one is wired on the top, and then it goes underneath this one. This one's wired on top, and it goes underneath this one. That's like that stack of batteries I was telling you. So the batteries have a positive end and a negative end. And when you stack them up on top of each other, those make electrical contact, and you get a higher voltage. So these are like stacked batteries. You can think of these as a really flat battery, basically. And then up at the top, this is called a bus bar. So all of these silver ribbons come up to this bigger silver ribbon, and this combines all the output of this polymer panels into this. And then they kind of disappear behind this little sticker here. They go back, spin this around. Into the junction box. So the junction box takes the output of all those cells and collects them into these wires. And these wires are weather sealed and strain relief so that they, if they get tugged on a little bit, they're not going to rip out. And then you've got a positive wire and a negative wire. And again, it's kind of like a battery, the top and the bottom, except here we've got 37 volts for each one. So this particular panel will make 260 watts in full sunlight at what's called standard test conditions, which is 25 degrees Celsius. Realistically, normally we're operating a bit hotter than that. Yeah, that's how these panels are rated, is under a specific set of conditions. So this is a 260 watt panel.
How much does each panel cost?
Wholesale cost, it's around $200. 5-6 years ago, it was about $1,000. Literally. It's really, actually, this panel 7 years ago would have been about $2,000. It just costs, it's dropping cost dramatically. Then we have, inverter cost, wiring cost, manpower, overhead, literally. Place to store all this equipment, have everybody work. So the panel itself, really can't get a lot cheaper if you think about it. You've got the construction that's designed and built to last 30 or 40 years, so they can't make it that cheaply. Getting down to the cost where it's, kind of like plywood, or maybe not quite that cheap, but it's just a building material now. It used to be, they were super expensive because you were paying for cutting edge technology, but these days, this technology is pretty well understood and known throughout the manufacturing industry, so costs really came down quite a bit. But then get into the specifics enough.
Yeah.
Okay, there's definitely more science behind it than that, but we just don't deal with it that much day to day. It's how many panels can we fit and how much power will it make. Basically, when we do a design, we start with looking at some of these power bills, and we figure out how much power they need. So we'll look at least the last 12 months. And then we'll get on Google Earth and look at their roof. And Google Earth has this neat little measuring tool, and we can measure out how much space they have. And there are a few rules we have to follow for fire code and things like that, and how much space we have to have around the panels. But we'll figure out how many panels we can fit, and then we'll look at the pitch of the roof and the azimuth. Azimuth is the direction on the compass that it faces. So north is 0 degrees, south is 180 degrees, so a full circle is 360. So we'll look at the azimuth, or the direction that they face, and enter all that information into a database from the National Renewable Energy Laboratory. That's a place in Golden, Colorado. They have data for the entire country on how much solar power they can get at that site. And then we'll take that the output data and plug it into an estimator, and then we hand it off to Ian, and he goes out and explains it all to the customer.
I do a lot of this.
So that's about it for the technical physical side of it. What's the other one?
I have 2 questions because
Okay.
we just went to K-State talking to engineers. What is your educational background in case if there, and also what do you think of solar roadways, driveways, and parking lots?
Sure. Well,
Practical or not?
my personal educational background is I got my degree at KU in environmental policy. So that kind of gave me some of the skills I need to talk to clients, mostly how to communicate with people and how to learn things. That's the big thing you go to college for. Environmental policy doesn't really relate exactly to what I do on a day-to-day basis. A lot of that came from just personal experience. Wiring car stereos, playing with remote control cars, knowing how much power a wire can take before it goes up in flames. Did a lot of that when I was a kid. All those experiences, all those different life experiences you have, you never know how you're going to use them or how they're going to fall into place later in your life. But having without going to college and without high school and all that stuff, all those little things, how to communicate with clients, that all really helps, and how to communicate with engineers that are certifying all these things. So as far as formal education, the environmental policy part of it helps me talk to our clients that are environmentally motivated, but a lot of them these days are financially motivated. It's actually something that's a wise investment these days, and environmental policy didn't get me too much on the financial part of it, but enough to keep it going.
You guys will find around here we've got kind of I'm going to call it a ragtag team of people who come from all walks of life that have kind of backgrounds and experience. Like a lot of us are environmentalists, a lot of us kind of have that's what got us into this. But we got people that were bakers, people that were everything that work here. So it's more of a kind of I don't know. You gotta kind of want to do this, and if you do, we can teach someone to do this job or one of the jobs here.
A lot of our installers actually came from the satellite TV industry because they're up on the rooftop installing satellite, running wires down to a device that controls how they work. So they've got some hands-on experience with attaching things to buildings and going up on ladders and handling wires and things like that. And so, there are lots of different work experiences people can have that lead you to a career.
But we also have installers that have degrees in botany and in the sciences. When we went to college, we realized that as much as they found it, they enjoyed learning that, it wasn't something they wanted to have as a career. They liked working with their hands.
Yeah.
We've got folks who've been in the Peace Corps and learned to fix problems, address problems and get their hands dirty to fix it. So people made choices, and then they find themselves here. One guy went to school to fix wind turbines and realized he didn't like climbing 300 feet above the ground to work with stuff. He just didn't he wasn't afraid of heights. He said he just didn't like being confined in space, and he wanted to work, because he doesn't mind being on roofs, but it was just kind of, he wanted to fix something, and he realized that being way up here wasn't it, but being on a roof worked better,
So solar roadways and solar parking lots. Think about it, glass is slippery. That's kind of the first challenge. I've seen that they've done like texturing on it, maybe they've used shattered glass or granulated glass to give it some traction, but that's going to cut down on the light coming in. So that's a challenge. The other challenge that I see is, roads as they are now, they use asphalt because it's kind of forgiving. It's a little bit elastic. It cracks. I mean, you can see cracks in asphalt all the time. They gotta come through every summer and seal those. Those things take a lot of abuse. I think solar roads have it's definitely a promising concept with a lot of challenges though. One thing we do quite often though is carports. So utilizing parking lots, unused space, it's already impermeable, which means water lands on it, runs off it, and so adding more impermeable surface isn't always a good thing. Making more runoff, more erosion, more flooding, things like that. But if you take an area that's already paved, cover it with solar panels, you keep the cars cooler, you actually keep the concrete cooler, it lasts longer, and you're making energy out of basically unused space, 10 feet above a parking lot.
So the solar panels are definitely strong enough to do it. Like we could stand on that solar panel right now.
Yeah.
And it wouldn't break.
You could park a truck on it.
Yeah.
But on 4 of them, there's a video on YouTube. Pull a Toyota Tundra onto 4 solar panels, one over each tire. They're pretty ginger about it. They're pretty gentle with it, but
Yeah, it also would help, for big cities for the heat gain. Probably,
yeah,
in the
definitely.
parking lots.
Solar panels in parking lots would definitely help right down with that. The heat island. Is that,
Yeah.
You guys all look bored out of your mind. What do you guys want to know? Come on, give us
Talking
some
to me for
questions.
too long.
Hit us with some stuff. We're happy to answer all of them.
Is like this, would you use like a different type of solar panel on a building than you would on a house?
No, they're all pretty much that solar panel. Yeah. What happens is instead of using 5, we use 100. For like a residential versus a commercial entity. It's really just about the amount of panels we use.
There's basically the industry's kind of settled on 3 different styles of panel. This is the most common for rooftop because it's manageable by one person. You want to go as big as you can to cut down on labor. There's a bigger size that's typically used on ground mounts where you're not carrying up a ladder, you're not hoisting it on a rope, and you can have 2 guys or girls carrying the panels over to the ground mount. That's called a 72 cell panel. They weigh about 10 or 15 pounds more. They're a foot taller.
That's actually what we have on our roof up here.
Yeah, they just fit better up there. So sometimes they just fit better, and we'll make that consolidation or consideration. But that's kind of a utility scale panel. This is a 60 cell panel. It's a little more common. And then the third style of panel is off-grid, the kind you see on like a school crossing sign or a water level metering station. It's just about this big. Puts out 12 volts. They can connect it to a battery easily. But the industry's really settled on this size of panel, which is really nice for us if we ever have to replace them. Any other questions?
Is there a threshold of, for example, you say you recommend to a homeowner they have like 40 panels and they say, well, can I just do 20? Does that make a difference? Or is there a threshold where you say, well, no, if we're going to invest in this, we have to do it to this degree?
Right. Well, there is kind of a, there's a lot of fixed cost. So any system has to be properly designed and has to have a permit taken out for it. We have to mobilize the crews. There's kind of this job-specific cost that doesn't change that much whether we're installing 12 panels or 100 panels. We call those fixed costs when we are pricing the system. So every system is custom designed and custom priced. So typically 12 panels on a house, it can be kind of expensive, and that's the cost per watt. So that could be around $3.50 per watt. But if we're installing 60 panels on a house, that can be down to $3 a watt. So the bigger you go, the cheaper it is for every watt that you get. So yeah, I mean, every homeowner has a different size that they need specifically, or that fits them best. And we often give them 2 or 3 choices. So it also depends on their usage curve. So how much power they use in July versus January, and how much power the system's going to be making in July versus January. And it gets all the way down to how much they're paying for a kilowatt hour in those months. So every system kind of has its own custom analysis done. So for some homeowners, 12 kilowatts might be the right size. For some homeowners, 3 kilowatts might be the right size. It just depends on their specific situation.
How long do you think it took you guys to like put the solar panels?
That one took us about a week. Could have been done a little faster, but you know, it's pretty far up there, and that roof that's over there isn't our roof, so we were being extra careful with our neighbor's roof. It's also a really steep roof, so if it had been maybe not quite so steep, could have done it maybe 3 or 4 days. Yeah.
What do you guys exactly do like when it rains or like is it like something like
That's what makes grid tie systems so good. So if we don't have enough solar power for a whole week, like this last December, it was just cloudy all December long. And we just didn't have that much output. But we're grid tied, so we're tied to the grid. If we need more power, we just pull it from the grid, just like we would without solar. But we can more than make up for it on those really sunny days like today. Like today, we're probably going to make more power than we can use. So when we're making that extra power, it just turns the meter backwards. So rainy days, cloudy days, if the panels are covered in snow, yeah, we'd like to be making that power during those hours, but it's not the end of the world, you know? Yeah.
So, speaking of environmental policy, yesterday in the Topeka Capital Journal, there was a story about what Westar is trying to do with like the grid charges, and so these guys just finished the environmental justice module, right? So, you know, I'm as a homeowner here in town, interested in doing that on my home, and he said before October 28th, you want to do that because they have a system, guys, where you can have zero down, which, you know, works for a teacher's salary. And they'll, you know, assess whether it'll be cost effective or not for your house. My house is too shady, apparently. That's all right. Huh?
Scott's kind of our expert on that one.
On the politics?
Yeah. Well, Westar, you know, being the major utility in the state, and we probably do about 50% or more of our projects in their territory at this moment. You know, they want to change their rates so that if you have solar, the price per kilowatt hour energy rate currently is at a place where it's cost effective to put solar on homes in Westar's territory. And they want to increase that rate by about 12%, which would be, from a business perspective for solar, it's good. From a customer's perspective, of course, you're paying more, and that's not good. Well, they're proposing to change the rate structure so that if you have solar, you have to pay a higher flat fee. So instead of $12 a month, no matter whether you use 0 kilowatt hours or 1,000 kilowatt hours, they're going to change that from $12 to $50. And if you have solar, you have to choose from them. You have to choose that rate, or you have to pay a demand charge, which is you've got your energy that as you use. It's kind of over the course of the month they measure the energy. The peak load, your demand is the amount you use at any one moment. And so you know you turn on if your refrigerator's running, your air conditioner's running, and you're drying your hair, you're going to have a high peak at that very moment. Even though you may only have your hair dryer on for a minute, the energy you use from the hair dryer may not be that much. You know, a toaster, for instance, uses about almost a kilowatt of power. So turn your toaster, it's got resistance heat. You know, that spikes it up, but it's only on for 30 seconds, so you're not using that many kilowatt hours. I mean, so your energy use is small, your peak is high. Most of us don't pay for that peak. We pay for the energy. Westar's going to require that if you have solar, you have to choose from paying a high monthly fee. Just it's going to be $50 up front, and then your energy rates are lower, or you have to pay for your demand. So whatever your peak is, it's going to be $3 per kilowatt or $10 depending on the month of the year. Summer will be higher. What that does to solar is it's going to make it pretty much uneconomical for the average homeowner to put it on. Because even though the price of solar has come down, it hasn't come down to 4 cents a kilowatt hour for the average person. It's come down to 9 to 10 cents. So we are concerned because Westar is doing this without studying the whole issue. I mean, they can't tell you what the cost of solar is to them. They've just put costs onto it in the attempts to curtail individuals from doing it.
So really, your only option would be to go off grid. I mean, to do
yeah.
like a hybrid system of
Yes.
wind and hey, we studied this algae building. It was really cool. The whole building in Germany was powered by algae panels. So cool. And then with the waste product became a food substance at the end. That was pretty cool.
Yeah, in Westar, going off grid will be your only option unless you're willing to pay more.
Yeah.
I mean, because right now we have one of our salesmen put solar in his house about 2 years ago, and we've run his numbers. If he'd be paying more on Westar's new rates for a full year, he'd be paying more than he did before he had solar. I mean, so it's going to be a penalty for a guy like him.
Yeah.
And he doesn't use a lot of energy, but we are concerned. We attempted to intervene in the process when they do a rate case. Since Westar is a monopoly, the state regulates them. They can't just change rates. They have to go through an approval process. And people who are affected usually get to come in and sit at the table and help influence that. And the state government determined we were not worthy of sitting at that table. So,
Of course not.
so solar will not be represented in this rate case, and we can only hope that other interests help kind of dampen that.
Yeah. So these guys are actually going to go
step out for a minute.
tour the Westar Energy Park. So you might ask the representative
Yes,
about
ask
that
them
when you
about
go on
that.
your Westar Energy Park tour.
Ask me why they don't want solar.
Well, I know they will tell you that the people who have solar pass on costs to other people, but since they've never, every study that's been done in the United States has shown that there's a net benefit to people having solar. Westar's making the assumption that there's a net cost, but they're just going to make it difficult for the individual.
But they don't look at all the costs.
Yeah. So anyway, that's kind of where we're at on that. Any other questions? You know, one of the things we're doing now too is, does everyone know what a drone is? We have our own drone, and we use it only to take pictures of our projects. You know, since most solar projects are on roofs, you know, you can stand down here and take a picture, and you know, you get a lot of sky and a lot of the side of the building. And we've been doing is after we finish the project, we're going out and putting a drone up in the air at different heights, taking a picture, and then we can give that to the homeowner. It's kind of like, and we have a record of what it looks like. I mean, from both for quality control, we can always look and you know, we want our projects to not only function well but look good. I mean, because it's part of a home. People care about how their homes look, and you're adding something to the roof that's going to change the look. We want it to be as attractive as possible too. So symmetry and making sure that loose wires and things aren't showing. I mean, everything should be tucked under the panels, and so we can do that. And then you know we can always fix it if something's not looking right. But also it's just a nice record of what we've done. And as we walk back through the building, we can show you a few of those pictures. Because a couple of them are on buildings that are so high that you can't see them from the ground. The drone can get you the whole thing. So we'll look at a few of the big pictures. Yeah.
There's actually a lot of buildings downtown people don't realize are solar. Like Liberty Hall, completely covered in solar power. Sunflower Bike Shop, completely covered in solar. The Polar Lofts, the low-income housing facility in East Lawrence, just completely covered in solar.
Yeah, we have pictures of the Polar Lofts. But
Yeah.
well,
Are any of those places going to be represented?
Why would the ratepayers be represented?
yeah, granted they denied us, they allowed Walmart and a refinery and two other
Maybe to the value of
come
it.
in. Yeah, and
Well, wait a minute. Now, Walmart does do the green lighting and all that.
Yeah.
So why not have a solar?
well, right, because they're reducing their electricity use. They keep because they're not using many lights. But no, it's just if they had solar on the roof, they would be more interested in this. So
This one here, that's on top of a church in Kansas City. This is actually Boss's house. Right top one there. That's another church there. This is what is this one? This is a farm implement company out in sorry, I don't know where that one is. You guys walking where are there's a bunch of ones. First one here is a house on Lawrence. This one's a big farm in northeast Kansas. I have no idea where this house is. Don't know where that is. I think that's the peak.
now that one is over by Haskell.
This one?
Yeah.
Okay.
And here's the Polar building, which is in East Lawrence. You can see the panels are flat, so you wouldn't be able to see that from the street. And if you stood up here, you wouldn't get to see the whole perspective, but you can see Katie's campus up here.
See your door?
And then this one is downtown Kansas City. You might be able to recognize, is that maybe it's either the Sprint Center or the Casey Star, maybe.
Yes.
So is like